Hello, everyone. First of all, I will introduce my team. My name is Stefan Filbert, and I'm presenting with my partner, Dodi Haryanto. Also, there is another people that join as our team, that is Arya Baskara and Alfie Story Zakaria. Today, my team are pleased to be present our paper titled Analyzing Customer Satisfaction Through Face Emotion Recognition, a comparative study of convolutional neural networks and non-short-term memory. So in today's competitive market, understanding customer satisfaction important for any business success. Our study explore which deep learning techniques, specifically CNN and LSTM, perform better to analyze facial emotions as indicators of customer satisfaction. Next, talking about customer satisfaction, what is activation and why it is important for our business? Customer satisfaction is crucial for businesses as it boosts customer loyalty, repeat purchase, and positive word of mouth. It fosters a positive relationship, benefiting both the business and the customer by ensuring a pleasant and fulfilling experience. Next, so there is several methods to measure customer satisfaction, but first I want to discuss about alt method for measuring customer satisfaction. That is by using equation. So in the slide, we can see that there is an equation S equals to sigma blah blah blah, which it is interpret that S is customer satisfaction, and there is EM, which expectation made, and I is importance, and then the N is number of events. So they use this equation uh, to measure the customer satisfaction, and then they plot the satisfaction by using the customer satisfaction metrics. Next, I will discuss about the trend method for measuring customer satisfaction. There is CRM, or usually we know as customer relationship management, or CRM. CRM is strategic tool used by businesses to manage customer interaction, track data, and improve service. It collects feedback, monitors social media, and analyzes interactions, enhancing customer satisfaction and business performance. Also, this method is commonly used for measuring customer satisfaction in several in company. Next. So next, I will discuss the future method or trending method. Maybe for now, it's already trending method for measuring customer satisfaction. That is deep learning. In this era, deep learning is commonly used in company, but not as common as CRM. Deep learning effectively measure customer satisfaction by analyzing unstructured data, which CRM cannot doing that, providing accurate insight to uh, many models and leveraging contextual understanding of language for business. Next, so this is our data set, which title name is Extended Chonkanidae, or known as CK plus. So this the CK plus image dataset consists of 593 facial expression image from 123 subject, which crucial for emotion recognition research. It provides fine-grained facial movement and emotion level, aiding in the development of algorithm for human-computer interaction and psychological studies. Also, as you can see that there is several class, which the total class is seven, uh, which as we can see also there is not really balance. To handle that, we split the data set into 80% trained data, 10% test data, and 30% for validation data. Next. So this is our model hyperparameter, which all model that we train, we're using this hyperparameter, which with this consistent approach, we assure comparability and reliability across the various model tests. And next, my partner will explain our model that we use for our research.
Right. So to tackle the task of image classification, there are several models that we are considering to solve this problem. The first one is convolutional neural network, also known as CNN. As well known, CNN has been widely used in the field of image classification. So we are basing this paper with the title Deep Convolutional Neural Network Architecture with Reconfigurable Computation Patterns as the main reference for our method for this research. And for the architecture of the model itself, since the input is two-dimensional, we are taking images as the input. And since the input layer of the neural network normally consists of one-dimensional series of neurons, so we are converting each pixel of the image by the process of convolution, pooling, and flatten to get the input layer of the neural network. So the second model that we are using is long short-term memory. In this area, aside from CNN, we also know that there is a VIT, and one of the building blocks of the transformer is long short-term memory. So we are also taking this model into account. And this is the paper that we are using as the main reference for this model. And as for the architecture itself, for LSTM, it consists of several important parts. There is cell state that is used to store long-term memory. There's also a hidden state that is used to store the short-term memory. Also, the LSTM block consists of input gate that controls the new information that will be passed to the cell state. There is a forget gate that controls the how much information that will be stored in the cell state, and then the output gate determines the output from the LSTM model. So for the results, will be explained by my partner.
Okay, for the result, I will explain the CNN result first. And as we can see based on the plot, CNN model has promising performance on CK plus dataset. The training accuracy is steadily increased and reaching around zero point 0.9, and while the validation or accuracy also improved, but there is some fluctuation. And the training loss decreased significantly, indicating that the CNN model has effective learning, whereas the validation loss stabilized after an initial drop. Overall, the model demonstrates the good learning capability and generalization on the CK plus dataset. Next, so we also plot the CNN confusion matrix to give more evidence about our training model. So as we can see that uh, in diagonal elements, we can see that most of the variable is predict predict correctly. Just there is some misclassification, but it's not much. And then it indicate that our model is significantly learning good. And next, So next, I will explain the LSTM training result. Based on the plot, we can see that LSTM model also exhibit promising performance on CK plus dataset. The training accuracy steadily increased, reaching around zero point 0.9, while the validation accuracy also improved, but with some fluctuation. However, the validation accuracy fluctuates uh, pretty high. And then next, we also plot the LSTM confusion matrix to look that our result is already good or not. Looking on the diagonal elements, we can see that LSTM also uh, give good performance at CK plus dataset. By we can see that also most of the variable is predict correctly, and then there is some misclassification, but it already good. And then next, my partner will explain the result of comparison.
Okay. So after comparing the both models that we're using in this research, which is CNN and LSTM, in terms of model performance, we can see that CNN method is better compared to LSTM. And if we are looking from the number of parameters, LSTM has less number of parameters compared to CNN. So in computational resource viewpoint, we can go for LSTM if we are short in resource. But if we are aiming for better performance, it is better to go for CNN. So to summarize our method as a whole, CNN has been widely used in image classification, but for this case, we are also comparing with LSTM that is proven to get quite good result. But in terms of model performance, which is the top one accuracy, CNN still outperforms LSTM for this face image classification case. So for the future works, as we all know, aside from CNN, in the field of image classification, the state-of-the-art model has been shifting towards vision transformer that is already proven to achieve quite good result. Also, if image labeling is expensive, some training methods like self-supervised learning can also be considered, especially if we are having less number of labeled data. So that's all that we want to present about our research work. Thank you.